All right, so we've gone through some basic concepts with our HelloWorld connector. You've learned a few things on how to get a connector available in the Scribe platform within your organization. And now we're going to take some of those concepts a little bit further, and we're going to look at a couple of advanced items. We're going to look at some real-world examples to differentiate from what we've seen in the bare bones in the HelloWorld connector. I'm going to take you through some real-world examples. We're going to talk about how to debug some of these connectors, supporting some of the features such as last run date and filtering, and mapping your API methods to the available operations within Scribe Online that you can map to within the connectors. So, for a real-world example, as you know, we have a series of connectors in our marketplace that include the GoToWebinar connector. Our GoToWebinar connector is actually included in the Scribe CDK as a sample. So here again is the website to get to the CDK. Within the CDK there is a project that is called the REST-sys sample. It is the full production source code for our GoToWebinar connector, which accesses the GoToWebinar REST web services. In that, we will discuss the connection UI, the metadata that it grabs from the REST web services, queries, and executes. So that's really what we're going to take a look at here. So let's take a look, and we'll look at the sample here. This is the code that you can download from the website, and as a matter of fact, let's back up here. I will bring you to the Connector Development Kit website. You'll be entering at this site. If you come down to Sample Projects, right there on the very first line is a link to the download of the zip file, which includes all of this information. It includes the replication services, source and target connectors, sample SYS connector, and the sample REST SYS connector, which is the GoToWebinar. So let's go back and take a look at some of that source code. So here's our source code. You can see that there are multiple projects in here. The top one is the REST web services sample. So we're going to take a look at some of the files within there and see how they differentiate from the HelloWorld example that you've been working on. When we take a look at the REST connector CS file, we see that we're housing most of the connector information in a single statement here. We have our supports cloud, we have our version number, we have the supports integration services basic maps. And we have the connector code that you're going to respond to. So here we have our pre-connect where we are returning OAuth information. We're indicating to this platform that this is an OAuth type connection, and that's the information that we're going to grab and pass back to you. And then later on, your connector has been given the connect command by the Scribe platform. And it will list to you the properties that it has stored for that connection, the OAuth information, and then you will make a connection here. Here's our connection. We're going to add an item to the connection info with our access token, etc. And when all is done, we're going to pass back information to Scribe indicating that we are connected. Okay, what is the next thing we're going to talk about? We want to talk about metadata. So we'll go back in here, and we have our metadata class, and how this differentiates from the HelloWorld example that you've been working with is that this is grabbing real metadata. With the HelloWorld, you did hard code object information and action information, operation information. And here in our production code, we have a metadata call, a get metadata provider call that grabs your metadata. It indicates that we have a metadata provider class here. Within this metadata provider class, we have several calls: retrieve action definitions, retrieve method definitions, which are not in use, and we have retrieve object definitions. And as you can see here, where we're going to retrieve the actual metadata from the GoToWebinar instance, we have a loop that simply retrieves all of that information in a reflective manner from the REST web services for GoToWebinar. And here is our individual call here, get object definition. We have an entity type and whether or not we should get the fields to go with that entity. We have an object definition where we're taking that information and we're dynamically putting it in here. So here is where, if you were creating a set of metadata that included objects that were read-only or objects that only supported a create operation, this is where you would put a switch case in here to pull out that information. So when you encounter that particular entity that is a read-only entity, you would come in here and within this line item here, supported actions, is where you would tell it that it only supports certain actions rather than the entire list of supported actions. And here we have an item here where this particular definition, it supports query, and we move on from there. So that's our metadata. In a similar fashion, we have back here in our connector base class, we have our information about execution query. So the execute query is called to your connector. This execute query hands off that information to a query processor class that has been created for this connector. And if we go into that query processor class, we have a series of entities that support the query. So an execute query is called in here, and here, as again, if we wanted to differentiate different entities in the metadata within the query processor, we can differentiate. If a particular entity is called, we have a switch case. For registrant, we're going to call a different API call to get the information back than we would for a webinar API call, etc. So here is where we would break that out. We would then break out to our individual functions that call those APIs for your connection. So that's an example of a real-world query processor where you have to make a determination as to how and where those API calls are made. So here's our webinar. We have a get webinars. We go to our definition, and here we're making an API call to the GoToWebinar client. And then we're passing all of that information back. It all bubbles back up into your query processor, bubbles back up, and that's your response to the Scribe platform. Again, similar fashion, the execute operation is going to work in much the same way. We have our execute operation. We're going to meter that out to the operation processor. We have an operation processor class, and we have an execute operation, and then we determine what operation was given to us. It is a create operation in this case. We don't have other operations available here, but we have a create operation. And then based on that information, we take the input from that create statement and we perform a bit of work on that. So here we create our registrant. If I go to the definition of that fellow, we have a series of API calls and results that come back to us. Again, bubbling up to the connector, and you return the operation result back to the Scribe platform. So that is an overview of again, a fast overview of what the differences are between the HelloWorld connector and the real-world connectors. You will be dynamically grabbing that information and looping through information as opposed to hard coding all of the metadata that you're interested in working with. Debugging. We have, when we talk about debugging in Scribe Online, we have two different worlds we're talking about. When you're talking about Scribe Online as the platform, we have the debugging feature where we can debug individual maps and get the result of the map. Well, that is a completely separate, as we know as developers, from debugging within Visual Studio. Within your connector, if you wanted to do a live debug of your source code, you will have to attach to the Scribe Core Processor Service, which is the Scribe Online agent that's installed locally on your development system. And then once you're attached to that and you've set your breakpoint, you can go into the Scribe Online platform and start your map or start whatever process it is that you need to debug. So let's take a look at a quick example. Again, we'll go back to our real-world example, and what I will do is I will come up in here to our REST connector. I'll come up to our pre-connect code. Pre-connect. I'm going to set a breakpoint right on the beginning of the pre-connect code. This is a real easy sample example. I'm going to attach. We will have to show processes from all users, and I will attach to the Scribe Core Processor Service. And now we're ready to go. Now, if I go into my Scribe Online, I come into my connections, and I attempt to make a new connection to my sample CDK REST system. I will get a wait statement, but if I go back to my code, we can see that we've very quickly debugged into our system. Now that works no matter what function you're working with. If you need to debug down here in the query processor, you can set a breakpoint in here and go back to your map and run your map. And then as the map begins to run, your breakpoint will be hit. So it's very simple to debug through there. And again, that is a completely separate item from actually coming into a solution, into a map, and using this debug function from within a map. That debug function will actually start processing data through the control blocks within your map. So a distinction that needs to be made as far as developing connectors. All right, let's move on to the next topic, which is supporting the last run date feature. The last run date feature is a feature that we value highly here at Scribe. We've got the same feature in our Scribe Insight product, and we support this feature in the Scribe Online world. What this does is within the Scribe platform, we keep track of the last time a particular mapping, integration mapping was run. What we do is within your map, you can select to use the last run date and only move that data which has modified since the last run date. It requires that your entity has a date field and that date field supports the used in query constraint. Oh, let's go forward again. So let's take a look at where that might be. So we're going to go back to our HelloWorld example, and we're going to take a look at our metadata and our object definitions, our object definition, and here we go within our object definition. So here we have our Hello World. We have an object with a single property, and this property will have to be a date type, and it will have to support the used in query constraint feature. So only those date fields that support that feature will be available for use in the last run date feature. So let's take a look. If I go into a map and I go into my query of that map, here's our last run date feature here. I can choose to process all records every time that this map is run, or I can choose to process only those records that have been created since one of these date fields. So we have a time modified field on this particular entity, and so each time that this map is run, the last run date will update, and only those records that have been modified based on this field will show up, will come through in your source data. So again, in order to show up in this list, it has to be a date field on your source, on your entity, and the date field has to support query constraints. Okay, let's talk about filtering. Filtering can mean a lot of things. We just talked about last run date. That is a type of filtering, but filtering can refer to a whole bunch of other things. We can filter our source data by fields. We can filter by last run date, again, as we already discussed. And on the target, we need filtering enabled in order to do lookups into lookup tables, and we need filtering to be enabled to do updates. So you need essentially a where clause to do your filtering. And within the code, you can use link to write your filtering criteria if you so desire. So let's go take a look at the different types of filtering that can be used. Okay, so here's our map. We go right into our source. This is our source filter, our source mapping, our source query here. We have our entity selected. We have our filter tab, and within our filter tab, we can choose to filter out or filter on all of those fields. So we can choose to filter a particular job status, give it a value. We can also and or those filters together, so we can have multiple fields to work with to filter by. Okay. The next thing is last run date time. We already discussed last run date time filtering. The other things are target lookups and target inserts or target updates. They need a matching criteria to be filtered by. So what I'm going to do is I'm going to add a lookup step in here for an example, and I'm also going to add an update step as an example. An upsert does not have filter criteria in it. So let's go into our lookup. We'll drill into it. Now we'll look up on any entity, and when you do that lookup, you need lookup criteria. So enabling filtering on your objects and on your fields will allow you to have values come down in this drop down. And again, we filter by the same method using our formula editor. And here we're doing a lookup for countries that equal, or for accounts that are in the United States. Again, we go into our update step. We have our matching criteria here. We choose an entity, and then we choose the criteria for which to match it on, typically account number. So if you have multiple matching items that you want to, or multiple fields that you want to match on. So enable filtering. Filtering is enabled in the metadata. So here's our metadata provider in our HelloWorld example. We have the property has these fields: used in action input, used in lookup condition, used in query constraint, used in query select, and used in query sequence. So all of those, typically I would set them all to true. You can see that for one reason or another in the Hello World we have some set to false, but unless there's a specific reason to not allow filtering by a particular field within your entity, I would turn everything on. That gives you the user of your product as much flexibility as he can get. Because what will happen is we'll go out, we'll grab the entire data set, and then it will be filtered within within the connector, it'll get filtered, or within Scribe, it'll get from the Scribe Online product, it'll get filtered by those conditions. So that's filtering, and we can move on to our next item. Operations. Scribe supports a finite set of operations: query, create, update, upsert, and delete. We've talked about what's required for those operations to be supported in your connector, but what we haven't done is we haven't talked about how your API maps into that. You may not have a query function for a particular entity within your system. So what you'll have to do is map those methods, one method to the other. And the way we do that is as I've spoken about before. Mapping those items to your system essentially is working within your operation processor, making some determinations based on the operation type that was given to you. So if a create operation was given down to you, and what you really need to do is do a series of lookups before you do an insert, and some matching or whatnot. That create operation can be broken out within a switch case, and you determine what that operation means to your API, and then you send back the results. So that's one thing to think about. Simply because your API does not directly support these particular operations, most APIs and most operations that you want to do within your system will fall into that if you break out, you do a switch case and determine, okay, for this entity, I actually need to do these things. I'm going to do these things, transform that data back into the result set that I pass back to Scribe. All right, so we've talked about the difference between the HelloWorld and all the hard coding that we've done. We've talked about debugging the connectors. I've shown you how to debug, supporting the last run date, and filtering and mapping operations. So hopefully I've given you a lot of good information, and we can move on and to more successful connector concepts.